Good afternoon, everyone. Welcome to Saturday Science with Miss Steph. It is wonderful to be with you today. I hope that you are excited. I hope that you're ready for some science fun here from the Science Club Annex, as I like to call it. It is, like I said, absolutely wonderful to be with you. And today for Saturday Science with Miss Steph, we are going to continue our June theme with super absorbent polymers. And then we'll also be using a little hot water for some fun art. Once again, my name is Stephanie Farmer, and I am the Executive Director of Triple F Empowerment Inc., and you are here for Saturday Science with Miss Steph. So let's hop right into our activities. As I promised last week, we are continuing with some super absorbent polymer fun. And for today's super absorbent polymer fun, we are going to be exploring our polymer expansion with different liquids. We're going to try to use some water, some room temperature water. All right. We're also going to try to use a little peroxide. I love it when my students are always like, but it looks like it's water. Well, guess what? Let's see if it reacts like water. And then we'll also be using some salt water. So that's 3 different solutions that we'll be testing for today's super absorbent polymer adventure. Like I said, we've got 3 different liquids, but we are going to use, 1 super absorbent polymer. Thank you for joining me. We've got somebody on Facebook. Love it. Fabulous. Instagram, where you at? Come on, guys. Yes, so this super absorbent polymer is called water gel. And as you can tell, it basically looks just like some white powder. But guess what? We are going to add our liquids and find out whether or not this is plain old white powder. Right? As you can see, I've got my 3 sample containers right here. I have food coloring. And of course, let me grab my trusty dandy marker so that I can label my samples. The first sample is going to be plain old just water. Okay? First sample, ladies and gentlemen, will be water. And we're going to use green food coloring for that. Then we'll do our H2O2. That's what it means. That's why we call this peroxide, because it's 1 hydrogen per oxygen. All right, so hydrogen peroxide inside of this with our neon pink. And then our third sample is going to be our salt water sample. Okay. Thank you so much for joining me today for Saturday Science with Miss Steph. Guys, we're having fun with some super absorbent polymers. So let's go ahead and add our liquid first, and then we'll use this measuring implement, little scoopy woo, to add our polymer to our cups. Okay, guys? It's gonna be fun. All right, so one of the reasons why I'm using a beaker is so that I'm able to measure my liquids, because I want to make sure that I'm comparing. If I'm doing an experiment, if I'm doing a controlled experiment, you guys know that we only change one thing in that controlled experiment. And so I have to make sure that I have my liquid measured. I have to make sure that I have my solid measured properly so that I can say that I'm doing a controlled experiment. Or, as you know, I like to always say that it's similar to a controlled experiment. We're not really exactly going to get, come on, a completely controlled experiment just because of the materials that I've got available for us. All right, Facebook, let me still 2 minutes. A little bit more. All right, then, so that you can see what we've got going on here. Water, peroxide, salt, water. This is what how we're going to build our samples. Okay, we are going to make sure that everything is added in the same order. Okay, here we go. So my food coloring is going down first. Thank you so much for joining me, guys. We're having a great time. All right, we are adding that one in there. Our food coloring to our samples. And for those of you who have been around with me for a while, you know that I feel that color makes everything better. So that's why I add food coloring to my samples. And it really not only makes things better and more vibrant and more exciting, but it helps you be able to see what's going on in the activity, see what's going on with our chemical reaction. So let's go ahead and add our water. This is just regular room temperature water. Again, we're not testing the effects of temperature on our samples this time. So I need to make sure that my peroxide and my water are the same temperature. So they've been sitting out on my lab bench for a little while. Turn to make sure I'm able to see this properly. So I'm going to go 80 milliliters for all of my samples. Coming down to the level of it, bending down so that I can see, right guys? So that I can see what's going on and that I'm at the same level as my measurement device. Okay, this one I'm going to hold up for everybody to kind of see. Typically, you would not hold it up, right? That's not your proper measurement process, but I want you all to be able to see it because you're joining me, right? We're doing this together. Okay, so, I was rushing. Sorry. I did something wrong. Can you tell what I did wrong? I added water to everything. I was rushing. I got a little excited. Okay, I'm actually going to get rid of the water that's inside of here. I'm going to do that kind of off camera, right? Because this is supposed to be peroxide. Again, I got a little excited. Okay. But yes, we do need water. Okay, we do need water in these two samples, right? So yes, this is H2O2, ladies and gentlemen. Go pink, and peroxide is going inside of here. Looking, making sure that I'm going to be able to see it. There we go. Right? Then, so we have water in two of the samples, and then we've got somebody on. Thank you so much for joining me. I'm Miss Steph, and you are joining me for Saturday Science with Miss Steph. We're doing a little experiment with super absorbent polymers. Okay, down. There we go. I'm going to add some salt. All right, to my salt water sample. Okay. That's going to be the spoon for the salt water sample, folks. Okay. So we have our salt water sample. We have our just regular water sample. And we've got our peroxide sample. I am going to stir this one. Okay. All right. Stir this. Help that color mix in a little bit. You can see that the color is not mixing in very well into my peroxide, right? And then I'm stirring. Okay, this is our gel food coloring, very strong pigment there. All right, putting that to the side. There we go. This, okay, putting this to the side. Okay, ladies and gentlemen, let's make sure we are on track, folks. We've got our liquids set up. Okay, we have our 3 liquids. Now it's time to add our super absorbent polymer to each of our samples. Now, you know why I did these first, right? So that they can sit for 10 minutes and then we can check them later towards the end of class. Yep, you guys know that, okay? Meanwhile, let's go ahead and get my water warming because, like I said, we're using hot water for our science art activity. All right, so I've got my scoop. You see it? My scoop. Okay, so that's the one that's just going with just regular water. This is going into the peroxide. And this one is going into our salt water. Okay? One of the things I noticed with the salt water is that it's like sank immediately. Okay? And then this one is still kind of floating. And then this is just got something else going on. So for right now, I'm not going to touch these. All right? I'll put them to the side for us to check out later. Hi, guys. Thank you so much for joining me for Saturday Science with Miss Steph. All right, let's make sure I'm putting all of my materials back in a logical location. Okay? Saturday Science with Miss Steph, where we do 2 hands-on and accessible, easily accessible. These are materials that you can get, like, online, usually, for reasonable prices. Accessible science activities for school-age children. And guess what? This activity that I'm going to do, you can do with any age. All right? This next one we can do with any age. And we've got our hot water. You know, I truly believe that art and science are in concert. They work together. You need to be creative to be a scientist. You need to be creative to invent things, right? And so I always like to have an art project for you all to try and to look at how proportions relate, how the amounts of things that you're adding can change how your art activity comes out, right? That's a science principle. That's going into math, looking at how certain things that you're adding together mix together, right? That's chemistry, okay? And that's typically chemical engineering when you're trying to formulate certain paints. And today we are going to make paint. Now, what are we making paint out of, you're asking me, Miss Steph. Miss Steph, what kind of paint are we making? We are making finger paint today. Now, finger paint can be a bit of a challenge and be a little interesting, but we're going to make finger paint today. Our main ingredients are cornstarch, okay? Cornstarch and hot water. So I used a little kettle and heated up my water. Cornstarch and hot water. The water must be hot for this particular thing. You know that when we make our oobleck, right, our non-Newtonian fluid, we use room temperature water. But for our finger paint, we're going to use hot water. Okay? And I want you to just kind of observe my measurements. Okay? This particular We're going to use about a half a cup. And I'm able to measure on the side. So that's what I'm looking at. I'm looking at these measurements that are here. Okay. And then I'm going to add water, just a little bit of water at a time to my container. And I'm going to be stirring. So, do you need adult help for this? Absolutely. You're adding water and you're using hot liquid, right? So my folks out there who are awesome culinary artists, right? You should be able to recognize what this kind of is, right? This is we're essentially making gravy with no flavor. Yeah? And you'll notice that I'm going to add just a little bit at a time. And you notice that I'm getting this nice paste. Okay? And I need to make sure that I'm mixing. Once again, you can do this activity with kind of everybody in your family can join into this activity. But you definitely want to make sure that you have adult supervision because we are using hot water. You see I'm mixing. It needs to be mixed. Right now, it looks a little bit like icing. Okay, I'm going to add a bit more hot water, and you're going to start to see a bit of a change. So you see what I've got going on here? Okay. Welcome to Saturday Science with Miss Steph. Right now, I am showing you how we use science, okay, and the transformation of chemicals, the mixing and transformation of chemicals to create an awesome art project. And I'm mixing this together. I want to get out of hand here. I want to get out of hand. Okay. So, some alternatives that you have to using hot water is to making this on the stove. You can make this on the stove. Yes, you can. On the stove top. But it would be a little hard to make sure that you're seeing what I'm doing, right? If I were in my kitchen. All right. You can also put this kind of in and out of the microwave. So you're noticing you're getting this texture that's kind of really close to like pudding. Right? And FYI, sometimes there's cornstarch in pudding. Okay? Thickener that can go in the pudding. Take this out. Squirt this down. Right? And mix it a bit more. And you notice how I have this kind of, like I said, kind of pudding, bit of a pudding texture. Okay? It's very thick. All right. So for time's sake, I'm going to move on. But you can do lots of different things with this. And when you cook cornstarch, it changes color and you actually can get a more clear, a more like a transparent color almost. And so then well, not color, obviously. Transparency is not color, but you know what I'm saying. More a translucent mixture. And then when you add the color, you're not going to get it won't be affected by the white being in there, okay? But again, that would be if I were mixing this on the stovetop and had more time to mix it. But since we're together right now, I'm going to move on. This is our art project today. So we took our cornstarch, added some hot water, and created this base, okay? Now, the thing about finger paint is that you can use your fingers, right? So it's thick enough for you to kind of pick up and manipulate. So let's make some different colors of our finger paint in our cups. I am reusing cups from last week so that I'm respecting our environment. Okay. I'm going to use, let's use colors we didn't use earlier. So let's use orange, blue, and purple, 3 different colors. Yes, yes. So glad that you're joining me today for Saturday Science with Miss Steph for our art and science adventure, right? So we made something that I'm now turning into finger paint. It looks kind of a bit like pudding. Okay, putting this in here. Yes, yes, yes. Add, add, add. Distributing. Evenly distributing our mixture. Fabulous. Love it, guys. It's so much fun. And I have 3 different spoons here. Actually, I don't want to use it. I'm not going to use the spoons. Let's use the craft stick. Okay. And there we go, ladies and gentlemen. This is turning into paint. Hey, hey, hey. Doesn't that look cool? Doesn't it look awesome? Nice paint. Finger paint. I'm going to use one end for my blue. Okay. And we know that red and blue make purple, so I'm not contaminating when I come over here and I mix my purple. Right? So you can, right? You see what I have here? It's so awesome. You could let this sit to cool off a bit because we know that we just used something that we just used hot water to make this. Yeah. And so if we did not want to hurt little fingers, we would let this cool. And remember, Saturday Science is my ode to you. This is me doing things to give you ideas of what you can do at home with your science knowledge and family member to have some great science and art fun at home. Once again, it's Miss Steph coming at you for Saturday Science with Miss Steph. I'm going to dig in and I'm going to use the purple first because that's my favorite. And you see how it has a nice thick texture. Nice thick texture. And it is finger paint, guys. See how I've got that there? And you know the 3 ingredients that we use. And so you know that this is safe for family members of all ages. And that if we had little ones, they accidentally put it in their mouth, they would not get sick because it is just cornstarch, food coloring, and hot water. Yes, ladies and gentlemen, we are having a good old time. And you see how it's nice and thick and it lays very nicely on the paper. And of course, what you would do is really take your time and make an absolutely awesome art project. You know that how I feel about art, that art and science really go together and that we get to explore that a lot right here on this channel. Okay? See? So in itself, mixing the colors is an experiment. It is something that gives us an opportunity to see what happens when we mix colors, to see what happens when we mix this substance together. Uh-oh, I lost you, Instagram. All right. So, as you see, a multi-purpose for my water. Okay. And see, the food coloring is left on my finger. So if that's something that's going to bother you, this is me warning you that that could happen. All right. Let's finish up here by putting our finger paint to the side, which really fabulous, fun, awesome, super, super cool activity right there, ladies and gentlemen. Putting our finger paint to the side. And now let's explore. Let's observe and find out whether or not we got different reactions or if these three liquids reacted the same with this particular superabsorbent polymer. Typically, superabsorbent polymers function best when the liquid is water-based, right? Typically, you are using a water-based or water, right? Solution of water to make your polymer expand. Okay, that's really essentially the change that we're observing is an expansion change. What I'm going to do here is get this together so that you're able to see. I'm going to scoop out, I'll stir, and then scoop out a sample of each so that you get an idea of what's going on. Okay, so this one, as you can see, it looks like it's still pretty watery. Okay, so some expansion has happened, but not a lot. Okay, take this and okay, put that there since it drops a little bit. You see what's happening with paper towel. Okay, which we shouldn't be surprised because it's paper towel, seriously. Okay, but there's that scoop. Now let's look at our H2O2. Do you see what's happening? Okay, do you see our gel? This is pretty thick, right? Put that there. Do you see that, guys? Yeah, man. And then this is our water. Let's find out what happens with the water. Are you ready? I'm gonna dip in my spoon. I mean, very similar to my H2O2. This is like this. Okay? Right? If I touch it, it's kind of fun to touch. It's soft and it's kind of cool. And then this is like not just soft, it's like you can see I can completely flatten it out. And then using another finger, this one is soft. Okay? Soft, but it's solidified in a way. It's really absorbed. Okay? So, that's something that we learned. When you have salts inside of your water, the superabsorbent polymer has trouble sucking that up. Okay? And so you get this kind of mushiness. But when I had plain old water, I got this. Right? That's cool. And then when I had my H2O2, see, I'm having trouble. I'm not able to like pick it up all the way, right? I have to be more gentle. My H2O2 is more similar to my water sample, but there's still some textural differences. So, lovely scientists, thank you for joining me. That's it for our adventure today. Today we used our water gel and we tried it out, tested it out in 3 different liquids. The liquids we did were just plain old regular room temperature water, We used our hydrogen peroxide, which is just the 3% stuff that you get in the store. And we did a salt water solution. And then we moved on and we made some fabulous finger paint with just 3 simple ingredients: our cornstarch, hot water, and food coloring. So, my dear scientists, I want to say thank you for joining me. My name is Miss Steph, and I look forward to seeing you next week right here, 2:30 Eastern Standard Time on Facebook and Instagram Live. Be well. Okay, really, I'm going now. I'm going to press end. Bye, guys.